So in this video I am going to talk you through how to use the factor theorem and also how to divide polynomials. So my first example, I'm going to start off with factor theorem, and the question is: use the factor theorem to show that x plus 3 is a factor of f of x, where f of x equals 5x to the power 4 minus 45x squared minus 6x minus 18. So if I know that x plus 3 is a factor, to use the factor theorem I am going to do f of negative 3. So we need to understand functions to be able to sub this in. So I take the opposite, effectively I take the opposite of what I've got in the brackets here. So here I've got positive 3, so I'm going to take negative 3. If x minus 3 was a factor, I'd be substituting in f of 3, but it's x plus 3, so I'm going to do f of negative 3. I'm then going to substitute that x value into all of the times that I see x in the function. So 5 times negative 3 to the power of 4 minus 45 times negative 3 squared minus 6 times negative 3 minus 18. Now this could be calculator, it could be non-calculator. I'm going to do it with a calculator today, but you need to be really careful when you type this into your calculator. So here, 5 times negative 3 to the power of 4, please can I ask you to make sure that you put brackets in to your calculator when you type it in. So make sure there are brackets around the negative 3. If you forget to put the brackets in and just do negative 3 to the power of 4, you will get the wrong answer, because your calculator will do 3 to the power of 4 and then put the negative in front of it, whereas you want negative 3 times negative 3 times negative 3 times negative 3, because it's 3 to the power of 4, negative 3 to the power of 4. So when I do that, I get 405. I'm then going to do 45 times negative 3 squared. So 45 times negative 3 squared gets me 405. So when I take away this answer here, which is what I put into my calculator, take off 405. Then I've got negative 6 times negative 3, therefore that's going to be positive 18 minus 18. 405, take away 405 is 0, add 18 is 18, take away 18 is 0. So the fact that when I do f of negative 3, the answer is 0, this shows that there is no remainder. Therefore, x plus 3 is a factor of 5x to the power of 4 minus 45x squared minus 6x minus 18. You must make sure that you write this little justification. This is you showing that you can substitute it in. This is you justifying that you understand that this 0 means that there is no remainder when f of negative 3 is put into the function. So that's the first example. Second example I have got for you is this: f of x equals x cubed minus 7x squared plus 2x plus 40. Show that show that x minus 5 is a factor of f of x, and hence factorize fully. So what I'm going to do is I'm going to take this and I am going to do f of 5. As I say, take the negative, take the opposite of what you've got here, so I'm going to substitute in 5. So I'm going to end up with 5 cubed minus 7 times 5 squared plus 2 times 5 plus 40. So 5 cubed is 125. minus 7 times 25, which is 175, plus 10 plus 40. 125 take away 175 equals negative 50. Add 10, add 40 is going to get me 0. I have shown that there is no remainder. And I'm just going to justify that there. Hence, factorize f of x fully. So I know that x minus 5 is one of the brackets. I've got a cubic here, and therefore I'm expecting to see 3 brackets. So to do this, what I'm going to need to do is I'm going to need to play about with some numbers to work out what this is going to be. So I'm going to have x minus 5, x and a number, x and a number. X times x times x is going to get me that x cubed, because I want 3 x's multiplied by each other 3 times to make the x cubed. Now what I need to think about is these two numbers that go here are going to have to multiply with that negative 5 to make 40. Therefore, if I call this A and this B, A times B times negative 5, we know must be equal to 40. So we can eliminate this negative 5, get rid of this so that we're just working with the A and the B. So we've got A times B is equal to negative 8, and all I have done here is divide both sides by negative 5. So all of this divided by negative 5 leaves me with A times B, and this divided by negative 5 leaves me with negative 8. So I know that amongst these two values that these are going to have to multiply to make negative 8. Now this could be a huge number of combinations. It could be negative 1 times 8, it could be 1 times negative 8, it could be 2 times negative 4, negative 2 times 4. So what I'm going to do is I'm going to use the factor theorem to see if I get any that give me no remainder. So I've got f of 1. That would give me, is x minus 1 a factor? Does that make sense? I hope that makes sense. If I do f of 1, that's telling me, is x minus 1 a factor? So let's substitute it in to the original. I have got 1 cubed minus 7 times 1 squared plus 2x plus 40. Now, sorry, 2 times 1 there, sorry, made that error. I'm going to always start with f of 1 because it is the easiest one to work with. This gets me 1 minus 7 plus 2 plus 40. So actually I've got 43 minus 7. Well, that gets me 36. X minus 1 is not a factor. So let's try f of minus 2. F of minus 1, sorry. Let's try f of negative 1. So I'm going to do negative 1 cubed minus 7 times negative 1 squared plus 2 times negative 1 plus 40. That's going to get me negative 1 minus 7 minus 2 plus 40. So minus 8 minus 10 plus 40 is going to get me 30. So x plus 1 is not a factor. My next easiest number to think about is f of 2. So 2 cubed minus 7 times 2 squared plus 2 times 2 plus 40. So I get 8. 7 times 4 is 28, plus 4, plus 40. Some slightly trickier numbers that I am not going to waste time working this out in my head. I get here 24. Therefore, x minus 2 is not a factor. The next one I'm going to try is f of negative 2. Negative 2 cubed minus 7 times negative 2 squared plus 2 times negative 2 plus 40. So negative 8. Take away 7 times negative 2 squared. So that's going to get me 4. So 7 times 4 is going to get me 28. 2 times negative 2 is negative 4. So take away 4 plus 40. Add this all up. And I do get 0 this time. Therefore, I know that x plus 2 is a factor. Because I've done f of negative 2, that must mean that x plus 2 is a factor. So I now know, going back to what I did earlier, that x minus 5, x plus 2, and then x plus or minus, I don't know what it is yet, b is going to be my f of x. I know a times b is negative 8 from earlier. I now know that effectively that my a, so if I go a, I'll just put a plus in there just in case. So plus 2, so positive 2 times b gets me negative 8. So b must be negative 4. Therefore I can say f of x equals x minus 5, x plus 2, x minus 4. And that's negative, although I've put the plus in there, that is actually negative 4 there. Just to double check, negative 5 times 2 gets me negative 10, times negative 4 gets me positive 40, so that's going to get me that positive 40 on the end there. If you were to then expand this out, you would get that function that we started off with at the beginning. It can be quite a long-winded process, but if you are logical about your numbers and work with the nicest ones first, usually they keep them fairly nice for you, especially at Further Maths GCSE. So I did also think about a part B. So using your answer, solve f of x equals 0. So this is what I got for that first question, because it said factorize f of x fully. Oops. Show that x minus 5 is a factor, and then hence factorize f of x fully. That's what I've done here and written that in the bubble. My part B that I'm adding on for you now is solve f of x equals 0. So what I'm going to do is, this is my f of x, x minus 5, x plus 2, x minus 4 is equal to 0. And as you would solve a quadratic equation, you're just going to do exactly the same. So x minus 5 equals 0, x plus 2 equals 0, and x minus 4 equals 0. Add 5 to both sides. You may be able to do this straight away anyway, that's fine. X equals 5. Subtract 2 from both sides, x equals negative 2. Add 4 to both sides, x equals 4. And those are your final 3 answers to solving f of x is equal to 0. Okay, my third example for you. Hopefully this doesn't go on too long, but we'll see. My third example for you is, given that x minus 1 is a factor of 5x cubed minus 9x squared plus 2x plus a, find the value of A. So we know that when I substitute in f of 1, that will be equal to 0. There will be no remainder. So let's find what f of 1 is. 5 times 1 cubed. Remember, I'm substituting this 1 into the function here. I've gone f of 1 because my x minus 1 is a factor, so I'm doing f of 1. So 5 times 1 cubed minus 9 times 1 squared plus 2 times 1 plus a. So that gets me 5 times 1 cubed is 5, minus 9 times 1 squared is 9, plus 2 plus a. 5 minus 9 is minus 4, plus 2 gets me negative 2 plus a. We know that f of 1 is equal to 0, so if this is f of 1, that must be equal to 0. Add 2 to both sides, I get a equals 2. So that's more of a problem solving type question. Now moving on to dividing polynomials, so dividing these rather than using the factor theorem. So here we go. Use algebraic division to show that x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. I'm going to set up a division, a bus stop division as such, and I am dividing by x minus 2. I'm not swapping the sign this time because I'm dividing by this factor. I'm showing that it's a factor, so I'm dividing by that. What am I dividing? Well, I'm dividing this. Now I'm going to try and do this in colours to try and help you see what's going on and help you follow. So I'm going to say x cubed divided by x. So what is x cubed divided by x? Or what times x gets me x cubed? And that's going to be x squared, because x squared times x gets me x cubed. So now I've got this, I'm going to multiply it by this and by this. So x squared times x gets me x cubed, and x squared times negative 2 gets me minus 2x squared. With that, I am going to subtract it from what I've got here. Don't worry about the rest for now, I'm just working with this part here. So x cubed minus x cubed leaves me with 0. X squared, take away negative 2x squared. When I take away negative, I'm going to add it on, so I get plus 3x squared. Once I've got to this stage, I'm just going to bring this minus 4x, because there's minus here, minus 4x. I'm just going to bring that down to be on level with that 3x squared that I've just found. I'm now going to see what 3x squared divided by x is going to be, or what do I times x by to get me 3x squared. And that is going to be add 3x. Once I've got this, I'm going to divide it by multiply, sorry, not divide. I'm going to multiply this by each of those terms. So 3x times x is going to get me 3x squared. 3x times negative 2 is going to get me negative 6x. And again, I then subtract this. Something to just take note of, when you are doing the multiplication, so x squared times x to get me this x cubed, it should always be what you have above. So when I did 3x times x got me 3x squared, it's what I should get here. So that's just something to be aware of. Okay, so I've multiplied this by that, and I'm just going to subtract this. So 3x squared minus 3x squared gets me 0. Negative 4x take away negative 6x means I'm going to have to add on 6x to negative 4x, so plus 2x, and again I'm going to bring down that last remaining term on my polynomial. Finally, 2x divided by x, or what do I times x by to get me 2x? That's going to be plus 2. 2 times both of these, so 2 times x is 2x. 2 times negative 2 is negative 4. And finally, I then subtract that. 2x take away 2x leaves me with 0. Negative 4 take away negative 4, so add that on. Negative 4 add 4 leaves me with 0. Again, there is no remainder, which you can't see as I'm writing this. And there you have it. Obviously, you can do that with factor theorem, and you would just do f of 2 into the polynomial you were given, but the whole point for that question was for me to show you how to do the long division. 2 more examples. So f of x equals x cubed plus 6x squared minus x minus 30. Given that x plus 3 is a factor of f of x, factorize f of x fully. Now, although it doesn't ask us, because it says given that x plus 3 is a factor, it's not saying show that it's a factor. We will end up showing that it's a factor, but I'm not having to fully justify that. So we know that it's a factor, so when I divide the polynomial by x plus 3, I'm going to end up with a quadratic on the top here and this factor here. So x cubed plus 6x squared minus x minus 30. X cubed divided by x is going to be x squared. X squared times x is x cubed. X squared times 3 is going to get me plus 3x squared. Subtract that from what you've got above. X cubed minus x cubed is 0. 6x squared minus 3x squared gets me plus 3x squared. And bring down the next term. 3x squared divided by x is going to get me plus 3x, because x times 3x gets me 3x squared, and 3x times 3 gets me plus 9x. Subtract that from above. 3x squared take away 3x squared leaves me with 0. Negative x take away 9x is going to get me minus 10x, bringing down that last term. Negative 10x divided by x leaves me with negative 10. Negative 10 times x, negative 10x. Negative 10 times 3 is negative 30. Subtract that. Negative 10 take away negative 10 is going to leave me with 0, because negative 10 add 10x is going to get me 0. Negative 30 take away negative 30 again, so I'm going to add on 30 to negative 30, gets me 0. This is it showing that it is a factor, there is no remainder. That's lovely. We are asked to factorize f of x fully. So we know that x cubed plus 6x squared minus x minus 30 must be x plus 3 then multiplied by this. If I multiply these two numbers together, whatever they are, gets me this whole division. So x squared plus 3x minus 10. Now that might look like it is fully factorised. However, I need to look to see if this can factorise any further. So, can this factorise any further? Let's have a look. Two numbers that multiply to make -10 and add to make 3. How about 5 and -2? So this is going to factorise to x plus 5 and x minus 2. And then I've obviously got that factor still there. So this quadratic here factorises nicely into those two brackets. And obviously we've got that multiplied by that bracket. That is your answer, fully factorised. One final example for you. Solve x cubed minus 3x squared minus 4x plus 12, which is equal to 0. I'm not given any factors or anything for this question. What I am going to do is I'm going to use the factor theorem to find a factor of this. Then I'm going to do the long division to find the factors to then solve, as I showed you earlier. Choice is yours. You can listen to me or you can pause the video and give it a go yourself. So, using the factor theorem, I'm going to start with the easiest one, f of 1. Let's see. So, 1 cubed minus 3 times 1 squared minus 4 times 1 plus 12. That's going to get me 1 minus 3 minus 4 plus 12. 1 minus 3 is minus 2. Minus 4 is minus 6 plus 12 is 6. So x minus 1 is not a factor. Let's try f of -1. Remembering those brackets, please, with the negative when you're doing the powers, especially if you're using a calculator. -4 plus 4, nope. X plus 1 is not a factor. How frustrating. Right, f of 2. So I'll put that in brackets. I don't want negative, sorry. Sorry, let's just get a new piece of paper. Sorry about that. F of 2 is what I'm working on. It's because I'm looking at that -1 thing, I've got to put negative in. Right. 2 cubed minus 3 times 2 squared minus 4 times 2 plus 12. 8. 2 times 2 is 4 times 3 is 12. 4 times 2 is 8. And there you go. 8 take away 8 is 0. 12. -12 plus 12 gets me 0. Therefore, this tells me that x minus 2 is a factor. So remembering we were looking for a factor to divide this by to be able to factorise it fully. So now I can do x minus 2, x cubed minus 3x squared minus 4x plus 12. And to divide this, x cubed divided by x is x squared. I'm going to whiz through this. X squared times x gets me x cubed. X squared times -2, -2x squared. Subtract that. X cubed minus x cubed is 0. -3x squared, take away -2x squared is going to leave me with -x squared. Bring down this term. -x squared divided by x is going to leave me with negative x or -1x, x better. -x times x leaves me with -x squared. -x times -2 is plus 2x. Subtract that. -x squared take away -x squared is going to get me 0. -4x take away 2x is going to leave me with -6x. Bring down that final term. negative 6x divided by x is negative 6. Negative 6 times x is negative 6x, and negative 6 times negative 2 is plus 12. Subtract that, and I'm left with 0 and 0. Nice. Just confirms that there is a factor there of x minus 2. So I know that I have got, going back to my question, x cubed minus 3x squared minus 4x plus 12. That is equal to this bracket multiplied by all of this. So I have got x minus 2, x squared minus x minus 6 is equal to 0, because that's your function there, equal to 0. We know that these two factors multiplied together are equal to 0 then. I need to factorise this. So x minus 2, numbers that multiply to make negative 6 and add to make negative 1 are going to be negative 3 and positive 2. Yes, that works. So now I've got my three factors. I can say x minus 2 equals 0, x minus 3 equals 0, and x plus 2 equals 0. Add 2 to both sides, I get x equals 2. Add 3 to both sides, I get x equals 3. Oops, sorry. And subtract 2 from both sides, I get x equals negative 2. And again, there is your final answer. The three values that you were expecting to the original question that you were solving, which I've lost now. Don't know where it's gone. There you go. There's the final answer. I hope that that has been helpful and useful for you revising and working through factor theorem and also long division of polynomials.